So the next problem is the sixth question. In triangle ABC and XYZ, if angle A and angle X are acute angles such that cos A equals to cos X, then show that angle A is equals to angle X. So let us take two triangles and name them here A, B, C, and the other triangle is X, Y, Z. So he says that cos A angle equals to cos X. So given that cos A equals to cos X. Remember that acute angle is always less than 90 degrees, which is less than 90 degrees, which is below 90, like 60, 30, 45, 80. So these angles will be considered as acute angles. So now we know the sides formulas for the cos A. Before writing them, let us look at the sides here. So this is the angle here. The one which is opposite to the angle would be opposite side. Here it is the 90 degrees. So this becomes hypotenuse and the other side is adjacent side. In the same way, this is opposite, this is adjacent, and this is hypotenuse. So here we can write the sides formula for the cos A as adjacent side divided by hypotenuse. We know that the sides formula for the cos is adjacent by hypotenuse. Now for the angle cos A, that it would be adjacent side would be AB upon hypotenuse side, which is AC, and for the triangle XYZ, the adjacent side would be XY upon XZ. So AB by AC equals to XY by XZ. So now let us write them as, let us assume that both these things are equal to a constant term called as K. Now you can write it as AB upon AC equals to K, or XY upon XZ equals to K. Now here the term AC, if we shift the AC which is in the division to the other side, it becomes multiplied. So this becomes K into AC. And for XY, if the XZ is shifted here, then it becomes K into XZ. You can write it as dot, you are getting confused. So AB equals to K into AC and XY equals to K into XZ. If you see this thing clearly, you can write this term here in a different way. Here he has given that AB upon AC equals to XY upon XZ. So you can shift both these things here. AB upon XY equals to AC upon XZ. If you can notice one thing, the AB side, which is in the triangle ABC, is adjacent side, and the XY in the triangle XYZ, it is adjacent side. And here the AC, which is hypotenuse in the triangle ABC, and the XZ is hypotenuse in the triangle XYZ. Here you can notice that adjacent divided by adjacent equals hypotenuse side divided by hypotenuse side. So as per similar triangles rule, if all sides are equal, or we say proportional, then we say angles are equal. The angles are equal. Here in the question is asking us to prove angle A equals to angle X. So as per the similar triangles rule, if all the same sides are proportional to each other, then the angles would be equal as per side theorem. Side criterion theorem. So here we can see, as per the given data, we can clearly see that the adjacent side is divided by adjacent side and hypotenuse side divided by hypotenuse side is equals to k. You can write it as k. Now in this problem, we need to prove that opposite side, which is BC, divided by opposite side of YZ, which is YZ, BC divided by YZ is also equal to k. What we need to prove here? BC by YZ is also equal to k. If we can prove that thing, then all these sides, proportional sides, will be equal to k. From there, we can use the theorem called side criterion theorem, and we can prove that angle A is equals to angle X. So this is the thing about this problem. I have seen many students getting confused in this particular problem. It's very simple. So I'm repeating the thing again. Here in the question, he has asked you to show that angle A is equals to angle X, and in the given data it states that cos A equals to cos X. So the formula for the cos A side's formula would be adjacent by hypotenuse. So we write those formulas: AB divided by BC and XY divided by, AB divided by AC and XY divided by XZ, and let us assume that it is equal to K, and then we will shift them to the other sides here. AC equals to AB equal to K into AC and XY equals to K into XZ. So to find this thing, angle A equals to angle X, you need to have a clarity on how to do it. So if we shift the positions of AC and XY here you can see clearly. So if the XY is shifted here and AC is shifted here, AB upon XY and AC upon XZ. So here you can see AB is adjacent side of triangle ABC and XY is adjacent side of XYZ triangle, and AC is hypotenuse side of triangle ABC and XZ is hypotenuse side of triangle XYZ. So here we are proportionating the adjacent sides of both the triangles and hypotenuse sides of both the triangles. Now we need to proportionate the other two sides, the opposite side, which is BC divided by YZ. So as we know, to find the missing value in any given triangle, we use the theorem called the Pythagoras theorem. So let us use the Pythagoras theorem here. For the triangle ABC, let us write the general formula here: hypotenuse square equals to opposite square plus adjacent square. So the hypotenuse side of the triangle ABC would be, just give us a second. Yes. Yes, here you can write for triangle ABC, the hypotenuse side would be AC square and opposite side would be BC square and the adjacent side would be AB square. Now for triangle XYZ, the Pythagoras theorem, if you use the Pythagoras theorem here, so the hypotenuse side would be XZ square equals to XY, sorry for that. So the opposite side would be YZ square plus the adjacent side would be XY square. I hope you are clear till this. So now we know the values of AB and AC here, XY and XZ here. So we know the values of AB and AC. We know the values of AB, AC. AB, AC. The unknown value is BC. So to find the unknown value, we shift the other value AB square to the other side. So now this becomes AB square is equals to AC square minus AB square. AC square minus AB square. Here you can see clearly AC square, BC square equals to AC square minus, we know that the value of AB, we know that the value of AB is K into AC whole square. Here you can see the value of AB is K into AC. I have substituted the value here. Now you can see BC square equals AC square minus K square. The square will be for the two terminologies here, one for the k and the other for the ac square. Now here you can see bc square equals to, yes, you see ac is common in both the things. You can take it out, ac square is common. So 1 minus k square. 1 minus k square. In the first term, you can write ac square as 1 into ac square. So if you common out the ac square, you will be left out with 1, 1, and the symbol here is minus. If you remove the ac square, you will be left out with k square. Now let us solve this thing. Here we know that the values of xy and the xz, both the values of xy and xz. So xy and xz. We need to find the value of yz. So this becomes yz square equals to xz square. If the term is shifted here, then this becomes minus xy square. So yz square equals, we know that what's the value of xy? K into xz. So we substitute the value here. So we get k into xz whole square. So now this becomes yz square equals to xz square minus k whole square into xz whole square. Now here you can take the common of xz square in both the things. You can write it as 1 into xz square. So if we take out the xz square as common, the one thing that is left out is 1 minus, here the left out thing is k square. So BC equals to, if we send the square to the other side, it becomes square root AC square into 1 minus k square. So you can write them as it is multiplied. You can write them separately. AC square into root of 1 minus k square. Root of 1 minus k square. For the second term, the square is only for the k, not for the complete thing. Remember. So the square and the square root gets cancelled. So the left out value would be AC into root 1 minus k square. In the similar way, we will send the square to the other side. This becomes square root of xz square into 1 minus k square. So you can write it as root over xz square into 1 minus k square. You can cancel out square root, and you will be left out with yz equals to xz into root 1 minus k square. Now let us shift to the starting point. Okay. You can see clearly in the starting initial steps, you can see we have proportionate the sides AB and XY, which are adjacent sides, and hypotenuse on both sides, AC divided by XZ. Now in order to prove this theorem SSS, you need to proportionate both opposite sides. So in order to proportionate these sides, we need to divide BC upon YZ. So as you are dividing both sides, AB upon XY and AC upon XZ, which is adjacent by adjacent, hypotenuse by hypotenuse. So we need to proportionate opposite by opposite. Here the opposite side is BC, here the opposite side is YZ. BC and YZ. So opposite sides of triangle ABC and triangle XYZ are BC and YZ. BC and YZ. So we need to proportionate them, which is like we need to divide them. So here we write BC upon YZ. BC upon YZ. You can write it as AC into 1 minus k square, which is the value of BC, divided by the value of YZ is XZ into 1 minus K square. So here you can see the common term is 1 minus K square, 1 minus K square. So this becomes BC upon YZ equals to AC upon XZ. So let me draw the rough diagram of both the triangles here. A, B, C, X, Y, Z. So the angle was here and this was the 90 degrees angle. So at the starting point we have proportionated the adjacent sides, which are AB upon XY, and then we have proportionated the hypotenuse sides, which are AC upon XZ. This was the thing which we have proportionated at the starting. Now we have proportionated both the opposite sides of the triangles, which is BC upon YZ. So which is equal to the hypotenuse side divided by hypotenuse side, AC divided by XZ. Now from this you can clearly see that BC by YZ is equal to AC by XZ, which is already equal to AB by XY. So now you can write them as AB upon XY equal to AC by XZ is equal to, you can write AC by XZ, then you can write this AC by XZ is equal to BC by YZ. We know that AC by XZ, AB by XY are all equal to one single constant value, which is X. From here we have proved that all the sides of both triangles are proportionate. Here you can see again, let me recall the things for you. So adjacent value, which is AB, and the adjacent value of XYZ triangle is XY, and the hypotenuse value of the ABC triangle is AC, and the hypotenuse value of the XYZ triangle is XZ, and the opposite values of ABC triangle is BC, and opposite side of the XYZ triangle is YZ. Here you can see all the sides are proportional. From this you can prove by using side criterion. We can say triangle ABC is similar to triangle XYZ, which in turn states that angle A is equals to angle X. Hence proved. As mentioned, as the sides are proportionals, then the angles in the triangles will be equal to each other. From that we can write as angle A is equal to angle X. So this is the problem. I hope you are clear on this. Please remember these things clearly, that as per the similar triangles rules, if all sides are equal or proportional, we can say that angles are equal. So in this thing we have proved that all the proportional sides are equal to each other. At the end we have proved that all the proportional sides are equal to each other. From this we can use the SSS criterion, and we can say that angle A is equals to angle X, which he has asked us to prove. So that is the problem. So the next problem here is the seventh one. Given cot theta equals to 7 by 8, and he has asked us to evaluate 1 into 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. The first question, and the second one is 1 plus sin theta divided by cos theta. So the given value, which is cot theta equals to 7 divided by 8. The sides formed of the cot theta would be adjacent side divided by opposite. So you can take any random letters, as there is no mentioning that you need to use X, Y, Z or the ABC. So let me take this as the angle. So this would be opposite and this is adjacent. and this is the 90 degrees angle, so this will be hypotenuse. So the opposite value here is 8 and the adjacent value is 7. So in the question you can see that is asking to find the sine theta and the cos theta. In order to find sine theta cos theta, you need to have the value of hypotenuse. So in order to find the missing value in a given right angle triangle, we use the Pythagoras theorem, which is hypotenuse square equals to opposite square plus adjacent square. The hypotenuse side is AC square, opposite is AB square plus adjacent is BC square. So the value AC square equals, what is AB here? 8 whole square plus the BC would be 7 whole square. Now the AC square equals to 64 plus 49. So AC square equals to, you can add them here, 64 plus 49. 4 plus 9 is 13. 6 plus 4 is 10 plus 1, 113. So the value would be 113. AC equals to square root of 113. We do not have a fixed value for the square root of 113. So we will leave the value as root over 113. So the first question here is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. Here you can see the terms as a plus b and the other term as a minus b. So you have a formula for a plus b into a minus b, which is a square minus b square. So at the top here it is a plus b into a minus b. You can write it as a square, which is 1 whole square, minus, which is b, is sine theta whole square divided by 1 whole square minus cos theta whole square. So it would be 1 minus 1 square is 1, sine square theta divided by 1 whole square is 1 divided by cos square theta. Here you can substitute the sine theta sides formula as opposite side by hypotenuse and cos theta sides formula as adjacent by hypotenuse. Instead of that, you can use the trigonometric identities, which will be in the exercise 11.3, I guess. So let me tell you the sides formulas here. The first identity, the identity formula, which is sine square theta plus cos square theta is equals to 1. From here, you can write sine square theta as sine square theta equals to, you will be shifting the cos here, so this becomes 1 minus cos square theta, and if you wanted to find cos square theta, you will shift the sine theta to the other side, which becomes 1 minus sine square theta. Now you can directly substitute them here. 1 minus sine square theta is cos square theta divided by 1 minus cos square theta is sine square theta. We know that cot theta is equals to cos theta divided by sine theta. Now you can write this as cot square theta. We know that in the given question, he has given the value of cot theta as 7 by 8 whole square. Now 7 square divided by 8 square, which is 7 square 49 and 8 square is 64. So therefore, the value of 1 minus sine theta into 1 plus sine theta divided by 1 minus cos theta into 1 plus cos theta would be 49 upon 64. This is the first one, and now let us find out the second one, which is 1 plus sine theta divided by cos theta. You can write it as, you can split them. like 1 by cos theta, the symbol is plus, and you can write sin theta divided by cos theta. You know that 1 by cos theta is secant theta and sin theta by cos theta is tan theta. Let me write here. We know that secant theta is equals to 1 by cos theta and tan theta equals sin theta divided by cos theta. And also we know that cot theta is equals to 1 by tan theta, or we can write it as or you can write it as tan theta is the reciprocal of cot theta. So what would be the value of the secant theta? The sides formula for the secant theta would be hypotenuse side divided by adjacent side plus, you can, if you want to write, you can write tan theta as opposite side upon adjacent side. We know that the hypotenuse value was root over 113. Yes, here you can see the value of hypotenuse is root 1 over 13 and adjacent is 7. Now we substitute the values here as root 113 divided by the value of the adjacent side is 7 plus tan theta is obviously the reverse of the cot theta. We know that in the given question cot theta is 7 by 8, then the tan theta would be the reciprocal of cot theta, then you can write it reversely, that is 8 by 7. Now as the denominator is same, you can write as 7 at the bottom in the denominator, and you can just add them as root over 113 plus 8 divided by 7. So which would be the value of 1 plus sin theta upon cos theta. So this would be the problem. So I hope you are clear on it. If you feel any doubts on the current question, you can comment it. So here is the last question of exercise level point 1, which states that in a right angle triangle ABC, right angle is at B. If tan A equals to root 3, then find the value of sin A into cos C plus cos A into sin C. And the second question is cos A into cos C minus sin A into sin C. So you can take the values here, and he has mentioned that the angle is at B, 90 degrees at B, and the angle is at A. For the clarity, you can write it as A, B, C here, and let me write A, B, C again. We'll let you know. I have taken two triangles here. This is 90 degrees as per the given question. So the given value tan A equals to root 3. So you can write it as 1 into tan A equal to root 3. If you shift the value here, the one which is in the multiplication becomes division, or else you can simply write it as root 3 divided by 1. So we know that the formula for the tan A would be opposite side divided by adjacent side. Now, in the first case, it has the question mentioned that there are two angles, one is A and C. So the reason for taking two triangles is to give you a clarity about the angles and the given problem. So if this is the angle, this would be the opposite side, this would be the adjacent side, and the one opposite to the 90 degrees is hypotenuse. Now the angle is here, so then this becomes the opposite side, uh, this becomes the adjacent side, and the one which is opposite to the 90 degrees angle would be hypotenuse. So as per the data, opposite side which is root 3 and the adjacent side is 1. The value of BC is root 3 and the value of AC is 2 and the AB value is 1. So now we write the values for angle A first. So sine A, here you see sine A, cos A, sine C. So we find the value for sine A first. The sine A which is opposite by hypotenuse. So now you can write sine A equals to what is opposite, root 3, and the hypotenuse is 2. And for cos A, that is adjacent side divided by hypotenuse. Now you can write cos A equals what is adjacent side, 1, and the hypotenuse is 2. Now for angle C, so this would be sine C equals to opposite divided by hypotenuse. So which is sine C equals to what is the opposite side here, 1 divided by hypotenuse is 2, and cos C is adjacent by hypotenuse. Now cos C equals to what is adjacent side, root 3 divided by hypotenuse which is 2. So now let us substitute the values in the given question. The first question is sine A cos C plus cos A sine C. So what's the value of sine A is root 3 by 2 and the cos C. What's the value of cos A? That's root 3 by 2 plus value of cos A is 1 by 2 and the value of sine C is 1 by 2. Here you can write 2 into 2, 4, root 3 into root 3 whole square plus 1 into 1, 2 into 2, 4. So square root gets cancelled. So now you can write it as 3 by 4 plus 1 by 4. Here you can write the denominator 4 as it is same for both the things. 3 plus 1, 4 divided by 4, 4 ones are 4 ones are. So this 1 is the answer for sin A cos C plus cos A sin C. So now the second one, which is cos A cos C minus sin A sin C. So the value of cos A is 1 by 2 and the value of cos C is root 3 by 2 minus the value of sin A would be root 3 by 2 into sin C is 1 by 2. Now 1 into root 3 is root 3, 2 2s are 4 minus root 3 into 1 is root 3 divided by 2 2s are 4. Root 3 by 4 minus root 3 by 4 which is 0. So for the cos A cos C minus sin A sin E, the value sin C, the value is 0. So these are the problems of first exercise. All we have discussed all the 8 problems of the exercise 11.1. I hope you understood all the 8 problems. If you have doubts in any problem, you can comment it so that we can discuss the problem in the next video. So please do like the video and subscribe, and if possible, try to share the video. Thank you. Have a great day. Bye bye.